I was just about to do that. Started recording. Okay. So, let's say, what do you think A is? What kind of test would you use for A? Okay. So yeah, that looks like a geometric series. I would break it into two separate sums. Excuse me, one with 2/6 and one with 4/6. Both of them would be less than 0 or less than 1 absolute value. So they would both converge and you could find a sum for that one. How about n? What would you do to, how would you solve n? You can't see n, sorry. Okay, got a couple answers there so far. That one, I'm thinking I would do the ratio test. Right, that n factorial is a key to use ratio test. I think if you tried the root test, it would be a little ugly because you'd have n factorial to the 1 over n. Okay, um, how about e? So yeah, that one's looking like a P series to me as well. Good. Um, how about F? So F, I think you could come at it with a couple different angles. Um, comparison test, limit comparison test would both be good. You could try and factor that denominator, right? Because it does factor, and it would turn into 3n squared plus 1. Or 3n plus 1, quantity squared, sorry. So you could do a integral test. You could do a u sub for that one. So that one's got a lot of different options. You could also try to prove whether it's telescoping or not, right? What about M? So it is an alternating series, but because of that n factorial, I think ratio test is the best for that one. Right, that cosine n pi throws you off, but that n factorial just a little confusing, but it can still be done as alternating. It's just, I think ratio test is the best one for that one. P is certainly alternating. What about H? So I see you said comparison. For that one, if you did a comparison, you would end up with um, or there's no terms other than the ones that are on top and bottom already, right? So there is no other option for the what do you call it? The dominant terms. They're already just a single term. But maybe what you meant was potentially using a ratio test. But again, you would end up with a log of n plus 1 over log n, and that's not very fun. So I think that one is best treated with an integral test, right? Because the derivative of natural log is 1 over n, so you've got your u and du there. Yes, you could use the root test for p as well. And actually, that would probably be the best option. All right, so how do you guys feel about looking at a series and deciding whether it's a good choice or not? Or what's the best choice to use for it? I mean, like, what's the best test? Okay. So I'll tell you right now that I don't have the test in front of me, but I'm from what I remember, I think I gave you maybe 4 or 5 problems where it just says, you choose the test, test the series, tell me if it converges or diverges. Another clue I can give you is, again, remember I said there were only 2 series that we started with where we could find the sum. They were the geometric series and the telescoping series. So if I remember correctly, there's a problem that says, here, or look for 2, or I give you 2 series, and I say, prove whether the series converges or diverges, and if it does, give me the sum. So obviously it can only be one of those 2, right? Because we've only found sums for 2 different types. All right, so Tom, you say, so as long as we can solve. Can you elaborate? I don't know what you mean. And while you're doing that, I'm going to go ahead and Start writing J up here on the board, and then I'll switch the screens over for you guys. So yeah, there is no, for the problems, they don't say you have to use a certain test, but there are obviously ones where certain tests do not work, and there are ones where certain tests work really, really well. So yeah, if there's a problem that could be done with a comparison test or an integral test, and you choose to do integral, that's fine. All right, so the third root, 7 plus n to the 10th divided, or sorry, on top is 3n cubed plus 4, and it's the sum from 1 to infinity. All right. Do you mean me answering you, Ken? Or that when you guys type and then how long it takes for you to get to me? Okay, so I had someone ask me to do this problem. Do you have an idea on how to begin? Focus keeps going in and out. All right, so you're suggesting limit comparison. So let's see if we can try that. Excuse me. So my B sub n would be the dominant terms. The dominant terms here are 3n cubed and n to the 10 thirds. So this is 9 thirds, that's 10 thirds, so that leaves us with 1 over n to the third. That's a p series, right? P is 1/3. It's less than 1. What does that tell us? So the reason the 7 disappears is as n gets larger, and it really doesn't have to get that large, right? What's 2 to the 10th power? That's going to be what? That's 1,024. That's already pretty big compared to 7. So if I were to try to say what's the dominant portion here, it's clearly the end of the power. So after n gets to 2, 3, 4, 5, this 7 doesn't make a whole lot of difference. So we can just drop it. That's how we get our dominant term. Sorry, that's kind of blurry. That's a 10. So yeah, this is divergent, right? So what does the, say, limit comparison test tell us? So if we take the limit, n approaches infinity, of an over bn, so I just plugged it back in as the original form. Sometimes that's good, sometimes it's not. I think maybe in this case it'd be better to plug it in the simplistic form. So this is limit, n approaches infinity. So 3 plus a third, that's 10 thirds. So you'd want to divide by n to the 4th in there, and if you bring it out, it becomes n to the 4 thirds, right? So it would look like that. So let's see, that simplifies to I think this is going to give us something ugly, isn't it? Because this is going to be 3n squared, and then we're going to get 4 over n so when I still try to plug in infinity, I get infinity because of this n squared. So I think maybe we should do comparison and not limit comparison for this one. Was that supposed to be? Yeah, it was supposed to be the 10th. That's what happened. That'll help us quite a bit, won't it? Sorry about that. Okay, let me fix this now. There we go. Silly, silly me. Alright, so then when I try to take the n to infinity, everything divided by n goes to 0, and you get 3 over 1, or 3. That's a constant that's greater than 0, so by the limit comparison test, both series should diverge. Sorry about that, that was really silly. Alright, what else do we have here? Yeah, everybody caught up and understand now? Right, I accidentally made that n to the 4th. Original problem was n to the 10th. Alright. So again, I'll ask everybody good? Did I confuse anyone? How about the gentleman that asked the question? Are you good? You're all done, Tom? We don't need any more review? Okay, someone asked me to do 4b, okay. So that's the Maclaurin of cosine of 2x. You start finding derivatives. There we go. All right. So derivative of cosine, bring out the 2, and then derivative of cosine is a negative sign. So every time we're going to get a 2 out in front. Derivative of cosine again is going to make this one plus. And again, we get cosine. Maclaurin requires that we plug in 0. So I need f of 0, f prime of 0, double prime, triple prime, and the 4th derivative. all evaluated at 0. So cosine 2x, or anything that's got cosine, the cosine portion is going to become 1, which means we just get the coefficients. And any of the terms that are sine of 0 is 0. So that gets me the first 3 non-zero terms. So you start writing out your Maclaurin series. So the first term, right, it's just f of 0 plus, and if you want you can write that over 0 factorial and times x to the 0, but you don't need those. Then you're going to have plus, the next term is 0 times x to the first over 1 factorial. Then minus 4x squared over 2 factorial. Plus, the next term is 0. It's x cubed over 3 factorial. And then finally 16x to the fourth over 4 factorial. And of course this keeps going, but that's all we have. So that's 16x to the fourth over 4 factorial. Let me just write it down here because I see the glare there. Okay. Yeah, if it was signed, you'd have to do 5 of them, or 6 of them, right? Because it would start at sine, cosine, sine, cosine, sine. So yeah, you would need 6 terms, or 5 derivatives, just to get 3 non-zero ones. Alright, so let's just write what's left after the 0 terms go away. So we've got 1 minus 4x squared over 2 factorial plus 16x to the fourth over 4 factorial. So that's when you have to start trying to decide what is the pattern here. So I notice I've got 1 here. This is 2 squared. That's 2 to the fourth. So I can rewrite them like so. And maybe it's a good idea that you guys go one more term, right? Because you can see the pattern in these two, but if you don't write this one out specifically as 2 to the 0, x to the 0 over 0 factorial, maybe you won't see it. So if you're looking for that extra thing to help you understand, maybe you just need one more term there to really start to see the pattern. So it looks like I got the sum. We got an alternating term. I got 2x in there. I have positive factorials. That's 2n factorial. That means I got to let n start at 0. Right, because 2 times 0 is 0 factorial, 2 times 1 is 2, 2 times 2 is 4 factorial. So we have to start at 0. If I start at 0, then negative 1 to the n is fine. Negative 1 to the 0 power is positive. Negative 1 to the first power is negative. And to the second power is positive. And then 2x is also 2 even powers, so to the 2n. That should be your closed form. And again, if you looked up the series for cosine of x, it looks identical to this, except there's a 2 in there, or in this case we got that 2 in there. So any other questions about that one? Yep, no problem. An end bound. In this case, it's infinite. If I asked you to use the first 8 terms and you make it 7, right? Because 0 is the first term. Yep, no problem. And I'll try to give you guys a better idea of what you should expect from the exam itself when we're all finished with problems. So any other questions that you would like me to do? Uh, 3A. Let me just see what that is. Okay, 3A is the interval of convergence, all right? And I'll tell you right now, without seeing the exam, there will be an interval of convergence problem. Darn it. So let's see, we've got sum equals 1 to infinity, look like 2, is it 2x minus 5 to the n all over cubed root n plus 2. So to start one of these, we got to use the ratio or the root test. I always suggest the ratio is the best first choice. So that's limit n approaches infinity. Plug in n plus 1 everywhere. So this becomes n plus 3. Multiply by the reciprocal of this. And remember that this all has to be less than 1. Ah, sorry, I couldn't see the screen. No, looks like it's okay. Dang, just can't get my throat cleared. Excuse me. Okay. So, 2x minus 5 there and 2x minus 5 there are both to power n. I can cross those out. This 2x minus 5 no longer has an n in it, so I'm going to take it out of the limit and to keep it inside the absolute value. Then I've got the cubed root over the cubed root, so just a single cubed root of n plus 2 over n plus 3. And then I would just divide each one of those terms by n. And what that's going to do is this whole limit now is just going to be 1. So I'm left with the absolute value of 2x minus 5 has to be less than 1. Or it's got to be between negative 1 and 1. Add 5 everywhere. Divide by 2 everywhere. So I get 2 less than x less than 3. That's my interval. I just need to decide whether these could be equal. So I need to test the endpoints. To do that, I need to take each one and plug them into the original. So, left, take the sum, plug in 2. So 2 times 2 is 4, minus 5 is negative 1 to the n. That looks like an alternating series that I believe is going to be decreasing. And we'd have to show that the limit as n approaches infinity gives us 0, which I'm pretty sure is going to happen easily. But let's make sure that the function is decreasing. And remember, when you're plotting this, you need to be doing it in do the absolute value of the function. Okay. So yeah, looking at this from 0 on, or from 1 on, right, this function looks like this. So it is decreasing. And so I just dotted the part that we don't really care about, right? That's the entire function. That's the part we worry about. So it is decreasing. And then if I take the limit as n approaches infinity, again of the absolute value, clearly that's going to go to 0. And that meets both criterion for an alternating series to converge, which means I include the left endpoint. So then I need to do the right one, which is x equal 3. So I plug that in. So this is going to give us 6 minus 5, which is going to be 1 to the n, which is really just 1. So how would we go about doing that one? What do you guys think? What test do we need to prove that is either converging or diverging? Okay, so I see a suggestion for a root test, and I see a suggestion for maybe a p-test, a comparison test. So a p-test, remember, it's got to be 1 over n to the p. So we definitely, there's something other than just n there. Okay, I see a bunch of people saying comparison. So what should I compare it to? Right, so 1 over n to the 1/3. So compare 1 over n to the 1/3. That's a p series that diverges, right? We did that one earlier. So the comparison test says, now if the b sub n diverges, then what do we need to prove? Right, we gotta prove something between an and bn. So even I'm a little fuzzy on this one, so help me out. Does this need to be an greater or an less in order for the other to diverge? If you guys aren't sure, I'll go look in my notes real quick. Sorry, I just keep clearing my throat. So if Bn diverges, we want An to be greater than. So good. The question is that true? So let's do the sum, partial sums for each. Right, do the first 10 or 11 terms or so. So I'm going to go into math. Then I'm going to go to option 10 or 0. Oops, it gave me the wrong thing. I want the summation. Why does it keep giving me the integral? Oh, okay. So we want to start at 1. And go to 10. And the first one is 1 divided by n plus 2 to the 1/3. And then we want to do the same sum but now just do 1 over x to the 1/3, or 1 over n. And I get that Bn is greater than An. So what does that tell us? I'm thinking maybe we should use limit comparison instead of comparison test. Because we were hoping to get the other thing, right? If we get this, well, that tells us nothing, so we've got to do something else. Dang it. So limit n approaches infinity, absolute value 1 over the 3rd root of n plus 2 times the 3rd root of n over 1. You get 3rd root over 3rd root, divide everything by n, you're going to get 1 over, you're going to get 1 out of that limit. So again, the limit comparison test tells us what? Should be that if we get a constant greater than 0 and it's real, then both series do the same thing. So this guy also diverges, and that means this is not included, which means that is my final answer. So that's a good problem for us to have done, right? I didn't just do whatever one I knew was going to work. We just tried whatever we thought might work, and it turns out we got to use a couple different tests to get there. So, any other questions that you guys would like me to work on? Problem 6 and 4A. I guess that's a maybe 4A. I don't understand what that means. All right. Before I do number 6, let me look at the test really quick. I might be able to give you a hint on that one. All right, there are currently 10 problems on the exam. 6 is not going to be one of them. Dang it. Did I lose a viewer just because they found out 6 wasn't one of the problems? We had 18. Yeah, 6 and 7 are the same thing. For A. So that's the same as 4B. You just got to take the derivatives. The derivatives there, a little tougher because it's a quotient. So if you want, we could do 4A. But before I do that one, is there any other problems that we haven't done at all yet that someone would like to do? All right, here's Tom. Are you still there? I'm going to do this. I'm going to stop the recording. Looks like I had to record paused, unfortunately. So yeah, I did prove that it converged. I did that when I said the limit of the function goes to 0. And you could do that again if you really wanted in this form. Right, the limit of this function very easily goes to 0. I did it at that one. So yeah, you have to determine the convergence first, which is by taking the limit, which I did. And then erased it because I started trying to plug in right away, but I had to do the decomposition first. So I just went ahead and did that and found the sum. Did I lose anybody on that one? These are not like 6 and 7. 6, I think you can prove converges using the theorem. But 6 and 7 ask for how many values of n are necessary, which means you'd have to do that error function. So that's completely different than 6 and 7. Sorry, the 1/9 over here is going to eventually cancel as well. So, Ken, you said, could you divide everything by n squared to determine the convergence? If you divide everything by n squared, I'm assuming you'd be taking a limit. And remember, if you just take the limit of a sequence inside of a sum, that is the test for divergence. That can't tell you if it converges or not. You're just dying for 4a, aren't you? For 2a, I keep getting 5/2 as the answer, but the solution says the answer is 9/2. Help. Okay, let me look at 2a. 2a is 2/6 plus 4/6, all to the n, right? Everything's to the n. So we've already said that those are both geometric series that converge. So you just need to find the sums. So sum 1 is going to be a, which is 1. No need for parentheses. over 1 minus r. R was what, 4/6 for that one? Yeah, no, 2/6. And the other one is 4/6. So the total sum is just this plus 1 over that, which is, let's see, it's 1 minus 2/6, that's 4/6. This is 1 over 2/6, or 6 over 4 plus 6 over 2, that's 18/4. Right? Losing it here? That's 9/2. And you said you're getting 5/2, but the answer is 9/2. My guess is you didn't notice that the sum started at 0. And remember that the geometric sum depends on where the summation starts. So if the summation starts at 0, it's 1 over, or a over, whatever the a value was. If the sum starts at 1, it's a times r over 1 minus r. That's what I'm assuming you did. So let me get this 4a out of the way so we can stop asking me about that one. 1 over 1 plus x. F prime, if you write this as 1 plus x to the minus 1, it's going to be minus 1 over x plus 1 squared. F double prime, it's going to be plus 2 over x plus 1 cubed. And third derivative, minus 6 over x plus 1 to the 4th. Plug in 0. You get 1. You get minus 1, 2, and minus 6. Yeah. Write out your series. Your series is 1 plus, well, in this case, minus 1x over 1 factorial plus 2x squared over 2 factorial plus, well, minus 6 over 3 factorial. And you simplify all of them, you get 1 minus x plus x squared minus x cubed. So it just goes up by powers of x. So it looks like the sum from n equals 0 to infinity, it alternates, so it's -1 to the n times x to the n. Right, so if you plug in 0, you get positive x to the 0 is 1. You plug in 1, -1 to the 1 is negative x to the first. Plug in 2, that becomes plus x squared. Plug in 3, becomes negative x cubed. Looks good. The problem's pretty simple, actually. I think maybe the only thing that might hang you up is either the taking the derivatives at the beginning, or not looking over there and going, well, I can't figure out that pattern, but if I were to cancel out some terms, it looks real nice and simple. That might have been where you got stuck. So I got time for maybe one more. If you guys have any other questions. Two F, that's another telescoping one. 2C. That one I think you could probably just use test for divergence, because everything's inside the log. You got some natural log 2n squared over 5 plus 4n squared. If you use the test for divergence, you just take limit as n approaches infinity of that whole thing. Am I still on the screen? Yep. And divide everything by n squared. It actually looks like if you do that, you're going to get 1/2, but test for divergence, you got to get what? That one I always forget. One more. The limit does not exist, or you get a limit that is not 0. Yeah, diverges. So, yep. So, Test for divergence is good enough for that one.